Welcome to STEMbassy After Dark. I am Raven Baxter, also known as Raven the Science Maven. I am a molecular biologist and science communicator, and I have created STEMbassy to bridge the gap between science and the public. In a weekly format, we work as a team, me and I think 5 other people now, and we bring you amazing guests in the STEM field to talk about current events, hot topics. We play games. But today we're doing something special. This is a more relaxed show. It's STEMbassy After Dark, and it's a time to chill, right? We've brought on a special guest, and I cannot wait to tell you more about them. Before we get started with our show, I just want to introduce our guests, and I want to bring on Jay.
Hello, people. I'm Jay, a UX researcher and international psychology student, passionate about AI, specifically in voice inflection and recognition, cybersecurity, and women empowerment.
Hey, Jay.
Hey.
All right, Amanda.
Hello, everyone. I'm Amanda. I'm a first-year PhD student at the University of California, San Diego. And if Anchor was not being very terrible today and being down for whatever reason, my podcast, Triplicates, would be out. You can follow us on Instagram and Twitter at TriplicatesPod to stay updated. And hopefully Anchor will fix their issues so we can get our first episode to your ears.
Hey. All right, Chanel, come on out.
Hi, everybody. I
Hey,
am
Chanel.
Chanel, also known as the Public Health Bae. I am a cell and molecular biologist. I currently work in human health and toxicology. From time to time, you'll see me on our regular show program put on my public health hat. But tonight is a little bit different. We're not doing public health hat tonight as a segment. It's going to be basically the whole show. We're talking about food safety tonight and bacteria and whatnot with our very, very special guest. Welcome to STEMbassy After Dark. We cannot wait to get into it with you.
Woo! And Ariana.
Hey everyone, I'm Ariana, also known as Ari the Ecologist on the internet. I'm a wildlife biologist finishing up my master's in wildlife ecology studying bobcats in New Jersey. Shout out to December, our producer in the background, helping our stream run smooth. Also, make sure you are following STEMbassy on Twitter and Instagram at STEMbassy, on Facebook as The STEMbassy, and you can find links to all these platforms at our website, stembassy.org. And don't forget to join us on Patreon at patreon.com/STEMbassy.
Thank you, Ariana. So we have a very special guest tonight. It's our first STEMbassy After Dark guest, so we're very excited to just relax with someone who is laid back and going to teach us some things about food safety tonight. So I want to introduce you to Dr. Dutton. Dr. Rachel Dutton is an associate professor of biology at UC San Diego. Dr. Dutton received her Bachelor in Science from UC San Diego and her PhD in microbiology from Harvard Medical School. The Dutton Lab is working towards characterizing the diverse species interactions that occur within microbiomes using simple, experimentally tractable communities such as cheese and model systems, or cheese as model systems, which is really interesting. I love cheese. I'm so excited. Dr. Dutton has been named as an NIH Director's New Innovator, a Packard Fellow, a Pew Scholar, and her work has been featured in the New York Times, Wired, NPR, and Netflix. She serves on the leadership team for UC San Diego's Center for Microbiome Innovation. So welcome to STEMbassy, Dr. Rachel Dutton. We're so excited to have you.
Yay! Thank you for having me. I'm so excited to be here.
Yes, we are so excited to have you. And if you guys probably don't know, but I will be rotating in Rachel's lab in January. So I'm very excited to do a little collaboration, before we get into it in January. So this is going to be super fun for me tonight. She's kind of my boss. We're drinking wine. It's a good time.
I love that you're able to have this type of relationship. That's really
funny.
Really awesome and cool.
It's a healthy relationship.
Yeah, I mean, we're gonna have a good time.
Yes.
Absolutely.
Absolutely.
Gonna have a good time.
Oh man, I'm here because we may talk about cheese, and I think.
Do you want to just
please
start with
let
the
us
cheese
talk about cheese.
conversation?
Yes.
Yes.
Wait, let's start there.
Please.
We're not even going to get to food safety, I think.
It's gonna be all cheese all the time.
Love me some cheese.
Do you want to talk a little bit about what you do, and then maybe we can let Raven hit you with some cheese questions?
Yes,
Yeah.
please.
So as Raven said, I studied cheese because it's amazing. I love cheese. I'm a microbiologist by training, and I really am interested in what microbes do, like out in the real world, out in the environment. And we hear a lot about like the gut microbiome and ocean microbiomes and all these different microbiomes everywhere. And they're, these microbes are doing amazing things, but they're super, super complex. And so it makes it really hard to study. And I'm a molecular biologist, I'm a microbiologist, so I want to be able to understand how things work. And so I wanted to find a system where it was simple enough where I could actually study what the microbes are actually doing, to each other. How are they communicating? How are they fighting each other? How are they helping each other? And it turns out, luckily for me, because I love food, fermented foods like cheese and wine and beer and bread and chocolate are all examples of places where microbes grow together as communities within these microbiomes, but they're much simpler than like the human gut or the soil or the ocean. Yeah, so Raven's making a grossed out face.
Raven likes chocolate.
I didn't
Raven
realize that cheese and chocolate had things in common like that,
Yeah.
Did you like cheese?
Hmm?
You like cheese, right? We're gonna make you a chocolate lover by the end of the night.
No.
No.
Yeah.
It's not gonna happen.
It's not gonna happen.
Yeah.
Wait, so I have a
Yeah.
question.
So, yeah.
Do you eat the cheese?
Did you
That
study?
we study in the lab, or
Yeah, like is
or
it like a regular cheese? Like is it just cheese I can get
It's
from
a regular
the store?
So it sort of depends on the type of experiments we do. Like some of the experiments are kind of a little more towards the ecology kind of questions. So we actually take cheeses from caves and bring them into the lab and isolate the different microbes. Yeah, caves.
What caves?
Yeah. What?
I didn't know cheese came in caves.
I told you it's gonna take the whole time.
Oh, okay.
Cheese is amazing.
Like
yeah.
from
So
cows?
cheese caves.
Wait,
Yeah.
Oh, okay. I'm thinking. Okay, go
I'm
ahead.
not there
But
yet.
they're like caves. They're
Like regular
just
caves.
like a regular cave.
And they're
But
naturally occurring cheeses.
They can be. So
That is
so
so
like
cool.
so like the milk comes from the animal, and then cheesemakers make cheese, right? They add certain types of bacteria and enzymes, and that causes the protein and fat to coagulate. So you get this sort of separation of all the solids and
Not
the
the curd.
liquid, right?
Not the
The
curd.
curd and the whey. The curd and the whey.
Oh.
And the curd is the fresh cheese. And so you can eat fresh cheese, it's fine. It tastes kind of like
Wait!
Wow,
Little
you can.
Buffett who sat on her tuffet
I
eating
know.
her curds in a way was
Okay.
eating cheese the whole time.
Yes.
yes.
See,
And
should
so,
make
okay,
fun
so-
of me.
I did
You
not
have
realize the answer just now.
I do that.
So you have the fresh cheese, and you could eat that, but it gets much more interesting if you put it in a cave, because if you put it in a cave, I don't know who figured this out. Like, I don't know why anybody would decide to do this, but caves are cooler than the normal, like, outside air usually, right? Because so people age like wine in caves and whatever. And so I guess somebody decided that they wanted to try and store the cheese in the cave to make it last longer. But what happens is that when you put it in the cave, it gets colonized by all these different microbes on the surface. And so you get bacteria and fungi and all kinds of different species growing on the surface of the cheese when it's aging in a cave for like months. And those microbes eat the cheese and create all kinds of flavors and aromas and textures. And so like a brie cheese is kind of like, that's only aged for like a few weeks or a month, month or two at the most. that's kind of like the simplest version of that, but there's like crazy cheeses out there that are made in different parts of the world. Yeah, I don't even remember what the question was. I'm sorry, Amanda. But
we went on a good journey, though. Whatever this was, I'm glad we went there.
Right. Wow.
Okay, so we're talking about bacteria and fungi being on top of cheese. Let's talk a little bit about bacteria and fungi that might be on top of our food. It is the holiday season. People are going to be baking a lot. I know I have a lot of free time when the semester will be over. I'm going to be out there slinging, baking baked goods. So we have some questions that we have. Don't laugh at me.
Slanging.
Yeah, you slinging the dough. So okay, I guess my first question, and it's me and Chanel were on the TL today. And I just, I brought my cookie dough here tonight.
Oh God.
We got a wrap.
Tonight, can we do that before we get any further, Amanda? Can we talk about what we all are? So tonight's a food special night, so we all have our own meals tonight. Okay.
This is my meal.
So Amanda, you go first. What's in your bowl, Amanda?
My bowl is just cookie dough. It's from Costco. It came in a 3-pound tub. It was $5.29, I think. I don't love eating on camera. I feel like if I'm going to eat on camera, someone needs to be paying me. So I'm gonna have my cookie dough.
Y'all, I want y'all to understand something. The reason why I'm laughing so hard is because there's a backstory behind it. Raven first put up a tweet asking, what flavor of ice cream has to go. I said butter pecan. Don't come at me either. I said butter pecan and pineapple. They gotta go. Then Chanel said I wouldn't be a good grandma. But then
no. Tell the whole story. Why wouldn't you be a good grandma, Jay? Why?
Because I don't like butter pecan. But
and then I said also, would you at least have what in your purse?
Butter pecan. Nobody feeds their child butter pecan. But
who says pecan?
That's how you say it in the South. You say pecan in Texas. I am with Jay 100%.
What do you say? Pecan? I don't
butter
say
pecan.
Yeah,
pecan.
No, it's whatever.
Butter pecan.
I'd rather not.
I got you, Jay. I got you. I agree. This Texas girl agrees.
That's how y'all are saying it down there?
Pecan.
Yes, that's what it is. It's not a pecan.
It's a pecan.
It's not a pecan. No.
It is.
We have to agree to disagree on this one.
But no, so Chanel said something about that. And then Amanda, you said that your favorite was chocolate chip, right? Or cookie dough, right?
No. I told Raven, I said what has to go is I said anything with raw cookie dough in it as ice cream has got to go. And I said people who eat that must be stopped. And so Amanda was like, I need to disassociate with you forever because of your comment about not liking cookie dough. And I was like, yeah, you guys are monsters because you eat raw cookie dough on purpose. And she's like, yeah, well, let's ask Rachel tonight. I said, oh, we can ask Rachel tonight on the show about this raw cookie dough eating, okay?
Just so you know, y'all, Chanel has very weird taste because Chanel doesn't even eat peas. She hates
peas are bad.
It's so weird.
I mean, that's okay.
No, peas and no, you can't.
But raw cookie dough is delicious.
Thank you. I see. I've already won this argument.
Issue. It's delicious.
It is. The cookie and the ice cream. Why wouldn't you put it? It doesn't have to be good. It doesn't have to be.
Is it okay though to eat? Okay, so this obviously I think it's like flourless, eggless.
Say it again, Rachel. Say it again, Rachel. Say it again.
No.
I can't hear you. She's got a big old she had a 3-pound tub in her freezer. Say it again.
I know. That's amazing. I can't believe you're eating that.
It's edible. It says edible, safe to eat.
Yeah. No, it's fine. That's fine. So regular cookie dough that you make, if you're going to make cookies at home, you put raw egg in it, right? That's the problem.
Yes. Yeah.
Cookie dough that you're eating right now, Amanda, I'm pretty sure that's pasteurized eggs in it, if any eggs at all.
Okay.
So I actually have some raw cookie dough ice cream in the in my freezer, so I looked at it earlier today, and it doesn't even have any eggs in it. So I think like depending on who's making it, like they're either using pasteurized eggs, so it's killing any potential salmonella, which is the thing that is a concern in eggs. Or if they're making it probably for ice cream, they don't even add eggs into the recipe. So, so it's delicious. Don't eat raw cookie dough that you make yourself with raw eggs, but eat as much of it as you want in ice cream or from a tub like Amanda's doing.
Amazing. With no eggs in it. The key is no eggs.
No eggs or pasteurized eggs.
That means this holiday season, Amanda, when you're making slinging the dough, you can't eat none of that stuff. That's what that means.
That's what I was gonna ask. Like it's like period, no dough, no licking the spoon afterwards.
Oh, so wait, is that okay to do?
I used to when I was a kid, but then everybody said we had to stop doing it. So yeah.
That's what I want to ask you. Because sometimes, when you're baking, especially if you're baking from scratch, I'll pour in, I'm not gonna lie, I'll pour in most of it and bake it, but there's a nice, some dough there. Batter. I'm eating it, kids eating it. So that's
it's like eating raw oysters or something like that. There's a risk, right?
Okay.
So as long as you're okay with some amount of risk of having food poisoning, then and you're not immunocompromised or in some other high risk group, then yeah, you can eat raw oysters, you can eat raw cookie dough. But raw cookie dough is a problem because raw eggs, there's some percent of raw eggs that have salmonella contamination. So,
man, guys, I got a story about unpasteurized eggs. So when I lived in Mozambique, all eggs were unpasteurized, right? Because like chickens laid them, and then like you grabbed them and you bought them from the farmer, and then you ate them. I decided to make a hollandaise sauce with unpasteurized eggs. And if you don't cook it properly, which is kind of hard to do, I discovered, needless to say, salmonella food poisoning is not a fun experience at all. So I would not recommend it to anyone. Yeah. It is not fun.
I agree.
Wait.
Okay.
Likewise, I got food poisoning once from raw oysters. It was not fun. Yeah.
Listen, I'm thinking about I used to buy, and this was before they made them safe, or this is so bad. In undergrad, I would stress eat raw cookies. Like I would get, the Pillsbury, and they have the cute little colorful shapes on them. And we would just eat them like that. Like I'd be like, oh, I'm stressed. Like let me go get 4 and finish my homework or whatever.
It's literally about the same.
I could have died.
You could have. Thank God you're healthy.
Yeah.
So wait.
The way I eat.
Okay, so speaking of how you cook food, is there any? Because I've heard it, but I don't know it. There's going to be a lot of people deep frying turkeys. Especially around Christmas time, right? Does that really matter if you fry food versus bake it?
In terms of the safety?
Yeah.
I mean, it probably tastes better if it's fried, right?
Yeah. It does.
The important thing is that you get the temperature of the meat up to the right point to kill. So birds like turkeys and chickens both can be contaminated with salmonella. And that's, from the chickens, it gets onto the eggs. That's why the eggs are concerned in raw cookie dough. And for turkeys and chickens, when they're raw, they can have salmonella contamination. And so basically, if there's any salmonella there, you have to, you want to be able to kill it so that when you eat the turkey, you don't get sick. And so it doesn't matter how you cook it. The important thing is the temperature that it gets up to. So you kill the bacteria, because bacteria basically can't live above a certain temperature. So the recommendation is 165 degrees Fahrenheit for fully cooked poultry.
I need to start measuring that because I just go by time.
Definitely measure it.
Okay. Okay.
Definitely. Yeah. Everybody should own even just a cheap probe thermometer. They're not, you can buy super inexpensive ones, and you just stick it in the deepest part of the thigh or the breast to make sure. And usually want to check it at a couple different places. because yeah, like sometimes like if the turkey is like previously frozen and doesn't thaw quite all the way,
Right.
and then you like cook it, but then the inside's still not quite as cooked, or I don't know. So yeah, definitely measuring the temperature is important.
Okay.
Unless you're just going for like way overcooked, and then it doesn't matter.
Oh.
While we're on the subject of frying turkeys, everyone be careful if you decide to do that, because when you put something with a lot of water and frozen in very hot oil, like you throw water on it and you see it spit, imagine that times 1,000 with a big giant turkey. You get a big turkey and oil explosion, which is not great for your skin. You don't want to end up in the ER with 3rd-degree burns. So please do your research on how to fry turkey. There are tons of fail videos online. I'm sure you've seen them. Don't be one of those fail videos. Do your research. I've never personally fried a turkey, but please do your research so you don't have an exploding turkey or fried other animal or object in your face, because that would not be good. We don't want you going to the ER for 3rd-degrry burns. So
no.
While we were
No
on that
burn,
topic, I
no
thought I would
salmonella.
mention that.
Yeah, just stay safe.
I think that's why, I've seen some of those failed videos, and they try to fry the turkey inside. Take it outside. It's for outside.
Yeah, you always fry turkey outside and never frozen. It should be defrosted first anyway. Like if you're frying turkey, did you really even season it? But I mean, that's just. I'm just saying, if it's frozen, did you really season it? So
in my head,
step one.
Okay, so if we're frying a big turkey, there's probably, I don't know, there's like gonna be leftovers, right? Let's talk a little bit about how long can we leave food out before we have to refrigerate it? What could be growing on there if we don't do a good job? How long can we leave it in the fridge?
Before you answer, I'd like to see because that's a good question. I like to see, like, how long do y'all leave y'all food out after you cook it?
I try to say like 2 hours. Like 2 hours. Sometimes it's 3. If I'm like, oh, it's too warm to put in the fridge.
I was gonna say I wait until it cools down first, because I heard that putting warm. This is another good question for you, also, Rachel. I heard that putting hot food in the fridge isn't good either. So I was always told to wait till it cools down first and then put it into the fridge.
But you can't leave it out overnight, right?
No.
Okay.
No.
People do that.
Like turkey?
No. Anything.
Like pizza, maybe. But
No.
Pizza's still questionable.
Still questionable, in my opinion.
Yeah, I don't know about that
but
one.
I don't study it, so I don't know. I haven't done a bacterial culture on pizza after it's been sitting out all night.
So I can tell you what the general recommendations are. So for how long you can leave like a cooked food out at room temperature. So after you cook it, you put it out on the table, and you hang out and eat it, and then maybe you forget to put it away or something like that. I don't know. So the recommendation is that you put it in the fridge within 2 hours.
Oh, wow.
And if you leave it out more than that, longer than that, then you shouldn't put it in the refrigerator. You should dump it, which is sad.
Wow.
That's that's the recommendation. I think there's some wiggle room there. And I think it really depends on what the food is and, like how warm is it, what's going on. So, but that's, I think, the conservative estimate. Mm-hmm. That being said, like there's plenty of times when I leave food out for longer than 2 hours. And then, so does that answer that question? But yeah, it depends on the food, right? And also, like, if it's super hot, do you put it in the fridge, right? That's not recommended, because then you're going to heat up your fridge and other things are going to spoil. So if you have something really hot that you need to put in the fridge, the recommendation is that you put it in like an ice bath or something, like to cool it down. Mm-hmm. So like hot stock or soup or something like that. You can make like the safe thing to do would be to put it in like an ice bath in a bigger pot or something like that, and it'll cool down really quickly that way. And then you put it in the fridge.
So then,
I have
go ahead, Ariana.
Depending, depends on how much it is, right? Like how big of a volume it is.
what about putting it in hot with the lid off in the fridge so like no condensation and stuff is forming, so like the condensation can still get out, and then like when you go and check it later, you put the lid back on after like an hour?
Wait,
I really don't think that.
what you cooking with no lid?
I'm just curious. I'm just thinking of all the possibilities.
I don't know that would make a big difference. I mean, you're still going to get all the heat in the fridge, which I think is the concern.
I see.
Yeah.
She's like, what if I give it easier access to the air in the fridge? What if I do that?
I mean, I usually leave it on the counter to let all the steam and heat dissipate before I put it in the fridge, but I was just wondering if that was an alternative. And now I see why that is silly.
Yeah. Okay, I have a question.
I promise I'm that.
So when you're reheating foods, I've heard a lot about, I don't know, this is a little bit out of bacteria, we're getting into like carcinogens or whatever. A lot of people are like, oh, don't reheat your food in plastic because whatever's on the plastic is going to get on your food when you heat it up. It's better to do it in glass and blah, 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 blah. So do you know like anything about reheating food versus in glass versus plastic?
I always reheat glass, or I never reheat in plastic. I think that there's like, I'm not an expert in this area, but I have a toddler at home, and so I don't know, for small people, I feel like there's more of a risk for any sort of chemicals going into their system, and the chemicals of concern in plastic are like hormone disruptors, which is a problem for like developing children. I don't know. So I think to err on the safe side, I don't microwave things in plastic.
Okay.
But it's kind of annoying sometimes because I do have Tupperware that's plastic, so then I have to put it.
Yeah.
It's a pain in the ass. But
it's convenient.
It is convenient. And it's not as heavy. Like when I bring food to lab, like it's like I don't want to carry this big glass thing.
Yeah. I know, it's annoying. Yeah.
I know I won't, and correct me if I'm wrong, but I know when I was pregnant the first time, when you first pregnant, you just read everything and everything.
And you're terrified of everything.
Absolutely. Yeah. And I used to warm up things. Don't judge me. I used to warm up things.
Judgment already is coming.
I know you are. On styrofoam. Just no big deal, because this is college. I'm used to still eating like that, ramen noodles in a bowl. And so you just put stuff on styrofoam, and then I'm reading like how it gets into your food, and then it gets into the fetus, and I'm like, oh my God, I will never use styrofoam again. So there's some truth to that though, right? Because the styrofoam, that just can burn versus the plastic, because that's a little bit thicker.
It melts too. It melts.
It does.
Yeah, I don't really know. I don't know like what the difference in like the chemicals that come off of one versus the other. But yeah, it does seem different. I mean, they're definitely different plastics.
Mm-hmm.
But I mean, it's not like you do it once and there's going to be a problem, right? It's a matter of like exposure over time. So, yeah.
So Rachel, can we take a step back, because I know this is going to scare some folks, but
can we talk about cheese again? Is that?
Like we can always talk about and alcohol beverages, but before we go back that far, I want to take one step back to talk about the recommendation is 2 hours, right? So during the holiday season, which we're coming upon, right? Everyone's some people might bring a dish to grandma's house or whatever. So the turkey's out on the table, mashed potatoes, carrots, veggies, gravy, all that stuff is sitting out on a main table, typically buffet style, right? Everyone goes around the table, gets what they want to get, fills their plate up, gets full, their bellies are already extended, they go back for another plate.
Yeah. And nobody wants to clean up because they're so
and the
full.
Food is out. The food is sitting there all day. And it's not that because we're not thinking about it consciously, we're like that's just what happens. So have we been doing holiday gatherings all wrong all this time? By leaving the food, you're like just sitting there?
I don't know. What else are you gonna do? I mean, I don't know. I don't have a better.
Not gather.
Not gather.
Like this year, don't gather.
Yeah. No
Yeah,
gathers.
I wonder if there's going to be like a lot less people going to the ER for food poisoning this year because people aren't gathering.
They're going to experiment.
Sorry.
For the frying their frozen turkey.
They'll be there for other reasons.
Bored. They're just bored. And then this is like a great time for people who know that they can't cook to show off on camera. It's like, oh my God, that looks so good.
Nobody has to eat it.
Right. But then they do it who we are.
So I have a question.
Calling me out, Jay.
Oh, sorry.
Oh,
Sorry. Go, Raven.
so I made mac and cheese yesterday, and I always get yelled at because I always buy cheese when we already have 50 cheeses in the fridge. So I said, my husband, I was like, I'm not gonna buy any cheese, but I recognize you're hungry, so I'm going to make mac and cheese with the cheese we have. All types of different cheeses, right? Some were like kind of crumbly. Some were, girl, I don't know. Like there's all types of cheese. Some were really orange, some were yellow, some were like X, Y, and Z. So I'm shredding the cheese with the cheese grater, and I make the mac and cheese successfully. But some of the cheeses, I didn't use some of the cheeses because they were far gone. I opened some of them, and they smelled like feet.
Mm-hmm.
I had never smelled cheese that went bad before. So I was surprised to know that it smelled like grandpa's.
Do you have any? Do you have it still?
It's gone.
Show me.
She wanted to see it.
Cheese doctor in the house. I could be cheese doctor.
Okay.
No, okay.
It wasn't
So
moldy. It had like a thin film on it, and it really smelled really bad. Like,
yeah.
Ladies and gentlemen, if you're paying attention, I want you to understand this is what scientists do. The first thing we said was, "Do you still have it?" Because she wants to see it. This is science all the way. This is science, and this is what we do. We look at gross stuff. It's like, really, mold? It's stuff like feet. Where's
Just send me your moldy cheese. The stinkier, the better. Yeah. Okay. So I get this type of question fairly commonly. Like, what if there's a little bit of mold on there? What do I do? But this is a really fun one. I'm glad that you said it smelled like feet, because there are bacteria that grow on cheese that are like close cousins of bacteria that grow on our feet and in our armpits. And
so cheese is real.
Yeah. So the reason that cheese sometimes smells like feet is because they have the same bacteria growing on them as feet do.
So what are they secreting that gives that smell?
So they're like there's a bunch of different molecules, but it's like volatile sulfur compounds, and then there's like breakdown products of different proteins and fats, and but like it's kind of cool because on our skin we have a bunch of protein and fat, and those bacteria are doing the same thing on our skin and creating these same like compounds that we smell as like foot odor and body odor.
Raven, do you still like cheese?
Cheese is like protein and fat too. Yeah, so
look at her face.
You probably had some of these bacteria growing on your cheese. That some people really like that on their cheese. There's like stinky cheeses, like usually we call them washed rind cheeses, where the cheesemaker when they have it in the cave, they wash it with like a salt solution, so it's really moist and salty. And those bacteria that create those stinky smells, like those like wet, salty environments, kind of like the ocean or skin. Anyway, yeah. So
or heard that.
Some people consider it like a delicacy to have cheese that smells like feet.
Oh, okay.
I have a question.
Did you feel that way, Raven? Is that how you feel right now?
Oh man. My question is, so when you have a piece of cheese that you've discovered has started to have a film of growing something, is it salvageable? Can you just cut off that piece, or do you just toss it all in the trash?
Yeah, I usually just cut it off. Like sometimes you'll get like mold growing on it or something.
You
It's
can just cut it off, throw off that end. The rest of it that looks good is good.
Yeah.
Look at Jay's face. So many faces today.
I'm not gonna do it. You know why? Because guilt by association. If you're close to it, you're all dirty.
Okay, so wait. So Rachel, I need you to confirm this for me, please, because here's my understanding.
Here we go.
My understanding is that cheese itself is moldy.
It's
moldy. We get is alive. Actually, what happens is they cut off the moldy part and give us the good part anyway. Isn't that how cheese works? Or am I totally missing the point on this, Rachel?
No, cheese is alive. Cheese is alive. Okay. And like, you know, unless it's like, you know, like Cheese Whiz or something like that, or like, you know, like American cheese, it's not really alive. But like any other cheese has living microbes in it. So there's a bunch of bacteria inside the cheese. So even if you cut off the stuff on the surface, there's still all kinds of microbes. And it's the same type of microbes that are in yogurt, right? So it's those kind of lactic acid bacteria type of species that create the acid in the cheese. And then on the surface, so like the aged cheeses, those are like completely covered in living organisms. What cheesemakers do who are making like cheddar, like in the US, they make them in these like 50-pound bricks, and they actually will like vacuum seal them in plastic and put them in refrigerators. So, and they'll like coat them with like antimicrobial compounds on the surface to prevent things from growing because they don't want like that extra microbiology to deal with. But like cheesemakers who make artisan cheeses and like the really good cheese, they actually encourage the growth of microbes because the microbes are what give it all the flavor. So.
See, Jay, it doesn't matter. You're eating bacteria. I said mold, so I apologize. But
well, no, there's
full of bacteria.
Like, so here's the thing, though.
Like brie and camembert, that's like mold on the surface.
Yeah,
I knew it.
Yeah.
I knew it.
Yeah, and that's why I don't eat those particular cheeses. Here's the thing.
So good.
Not those particular ones.
They are with the soft inside, squishy inside. It's so good.
No, I don't really like soft things. So I don't really like it. Or ice cream. Besides that, no. But okay. All right. This is just all too new. Okay, so my other question is, when the cheese molds more, I guess, or the mold that we can see after we buy it, right? Why is it that these cousins can make the cheese, like that part that molds gets a little bit slimmer? How come their cousins on your body doesn't make your body get slimmer?
Ooh. Oh, that's a good question. Why don't they just like ripen our whole body?
Right. Just what?
That's probably because our immune system exists and we've evolved to coexist with microbes and make sure they don't just destroy us while we're healthy. I don't know. I don't have a great answer for that.
that wasn't for you. That was like I hate now I know this and now I'm mad.
Like why don't we have mold growing all over us? And yeah,
they're not doing me any good that I want them to. Attack the fat.
Let's go like
attack the fat. You know, whoa, you see
I know, right?
Dang. Okay. All right.
That's pretty awesome though. So you also mentioned that chocolate is fermented also.
I didn't know that.
I didn't know that either. I didn't know that it was
anything delicious is because of microbes.
Okay.
So I knew there was a process, but I didn't realize how deep the fermentation went. I did know you had to ferment chocolate, but can you talk about that a little bit? Like just a little bit? Can we switch gears a little bit?
Yeah. So chocolate after they pick the cacao fruit, so the seeds that you eventually use to make the chocolate are inside the fruit. And so they pick these giant pods and they throw them in these big piles and cover them up. And so they go through this spontaneous fermentation process. And the bacteria that grow there in that fermentation, there's a lot of acetic acid bacteria and lactic acid bacteria. So they're producing a ton of acid. And that acid seeps into the seeds and it actually like releases a lot of aroma compounds inside the seed. So it sort of decreases the bitterness to some extent. So it's kind of like before they even get the seeds out of the fruit, they let the fruit ferment, and that improves the flavor of the chocolate itself.
Yeah. Interesting.
Yeah. That's
Wait,
really
I have.
interesting.
Oh, go ahead.
No, I was just saying it's really interesting because I knew there was a fermentation process, but I didn't realize how deep, how integral it was to the flavor. I just thought I thought it was just a part of the process, but it actually helps improve the flavor of the chocolate.
Oh,
Yeah.
I have sorry.
Yeah, go ahead.
This whole conversation sparked another question. Have you heard of the like mongoose that eat coffee beans and it goes through their digestive tract and it makes the coffee better? Does that have to do with micro like gut biome too, and like why it makes it like artisanal?
Wait a minute. Don't just go past that.
Acid, right? Isn't the acid process like scoring the actual bean?
Y'all really talking like, no, go back a little bit. Seriously, go back a little bit because I want to make sure that I heard it correctly.
Yes, some of the best coffee in the world has to go through a process. The coffee this particular coffee has to be digested by the animal first. Like they actually have these animals on their coffee, what do you call them? Coffee plants, plantations. And so they have to eat them first and go through that process. And the acid helps score and process the coffee berries. And so when they come out, now they can be processed into coffee. And it's the best coffee in the world.
That's great. So this is a normal process.
I mean,
no.
I don't think so.
Well, I mean,
That's what I'm wondering. That's where we get that. Like, hold on now.
What's normal?
Yes,
is that coffee.
Yes, Papa Smurf. Papa Smurf in the comments. The kivets, yes.
Civet.
It's not a mongoose. I was about to correct myself because I just
because when I had it in my head, I'm like, wait a minute, what are we doing?
Okay, so coffee is also fermented. It's kind of similar to chocolate. The berries of the coffee plant have the seed inside. The seed is eventually what we roast to make coffee. But that fruit, when you pick it, you can also let that ferment, and that can improve the flavor. There's certain types of coffees that are not fermented. There's like different ways of processing the fruit. But so like a lot of coffee is fermented as its initial stage. And then, so I don't actually know what happens in the gut of these civets when they eat the coffee, but I imagine there's some crazy fermentation process that happens. And then they poop it out, and then we
eat it,
roast those beans and drink it. I don't know. I've never tried it.
We roast it, grind it up, and brew it.
Yeah, exactly. So, yeah. But again, like pretty much everything delicious is because of microbes. So coffee, chocolate, cheese,
wine,
bread.
You just name my morning.
Amanda, I'm so sorry. Do you have a question, Amanda?
I had a question. I forgot it, but now I have a new question. So we're talking about microbes, and my friend, I remember she used to eat nutritional yeast. Like you just sprinkle yeast on things. Are there other microbes you can just eat like that, and are they good for you? Do they provide any, like it's like some sort of biomass?
That's interesting. Yeah, so nutritional yeast is just like dried baker's yeast, as far as I know. Well, like when we eat yogurt, we're eating tons of microbes. There's like billions of microbes in every spoonful of yogurt. The same is true with cheese. Like when we eat cheese, we're eating billions of microbes. If you eat like sourdough or kimchi or sauerkraut or any sort of pickled vegetable, there's going to be billions of living cells in it. But like just pure microbes that you like would eat, I'm trying to think of some examples. Natto is kind of a cool example. Have you guys heard of natto? It's like fermented soybeans.
Oh, yeah.
And soybeans fermented with this bacterium, Bacillus subtilis, and it produces this like slime. And
Wait. Say it again. It does what?
It produces a slime. It's like they're called exopolysaccharides. They're these sugars that the bacteria secrete from their cells, but they're kind of slimy. And so it grows on the soybeans and produces all this slimy stuff, and it smells like like it's gone bad. But it's a delicacy in Japan, and they eat it for breakfast.
The
with
soybeans
rice.
or the slime?
Mm-hmm.
It's all together. Yeah.
Oh, wow.
So that's kind of cool. People are starting to eat more like algae.
Mhm.
They're usually like cyanobacteria or other types of blue-green algae and like nutritional supplements. So yeah, but I don't know. I'm trying to think. If I think of other ones, I'll.
Okay.
We got
How
really
is it on
excited.
tonight? Can you see Scott's friend in the comments? He is on it.
Ectopolysaccharides.
That we go fast.
What about nutritional yeast? Because some people, like vegans, use it as a cheese substitute.
Oh,
It's okay.
Yeah.
It doesn't taste too bad.
it's not a taste.
It's kind of cheesy, but I mean, if you like cheese, it's not cheesy.
No, I mean
Not
just the nutritional yeast, just to put it on top of anything, or like salad. Salad, maybe there's a little texture, but to me, there's no taste.
I've got some in the kitchen right now. It's okay
You
on popcorn.
have a whole grocery store, and
Do you just scoop it? I just want to know what it tastes like, because like I worked in a yeast lab and it smells good, and you're like, I'm curious
Our
what it
producer
tastes
in the
like.
back said, update your taste buds. December said, update your taste buds.
What is your thing? It don't taste like anything.
Wow.
I'm trying to describe it.
It's kind of cheesy. I mean, not really. It's kind of like I mean, if you are a vegan, if you're a thorough vegan, like you really are a vegan, no animal products, I could see how you could like the taste. It's not bad. It's not bad. It's just not. If you are a cheese person, it's not real cheese.
No.
You know, you miss that cheesy flavor, but it's not bad. It's not. It's palatable. It's good. It's palatable.
Stop saying good and palatable.
It's
palatable. It's two different things.
It's palatable.
It is palatable.
Are there units of
It's not
measurement
good.
for taste? Is there a unit of measurement for taste and smell?
Oh.
No,
I don't think so. So one of the cheesemakers I work with, they have a score that they call DF, which is deliciousness factor.
I like that.
Wait.
And so they like rate their cheeses based on their DF score. But it's kind of like, because there's so many factors involved in how we like sense and smell and taste, there's not like one way to measure it. But there's all kinds of really interesting like science of flavor and stuff like that. But no, there's not like a scale like you have like chili pepper hotness, like Scoville scale.
Ooh, can we go back just a little bit? Because we were talking about, did we ever talk about preserving food? Or maybe there was just a question floating in my head.
Yeah, we didn't talk about it.
So I guess what would be, your recommendation on how to store food? Because, especially around this time, there's a surplus of aluminum foil and plastic wrap. Is there a thing that you should not? Because, okay, I'll say for some foods, like my grandma used to tell me, do not mix the plastic wrap with the aluminum foil. It's either or. Or you can't put the paper towel with aluminum foil. I'm not for sure why, but does that sound familiar? Or is there a recommendation as far as what you should or should not use?
I have never heard of any of that.
I never heard of that either.
Brad just she's like great grandma now. I don't know. Chanel, you said you heard something similar?
Yeah, and also it's really good not to put some foods are really acidic and will eat through the aluminum foil, depending on what it is. So when you sometimes you put aluminum foil on certain foods, and a couple days later you open it up and there's holes in it or whatnot. So some foods will actually eat through the aluminum foil. So
see, I thought somebody was in our food. Okay, got it. Because I did not do what I was told when I was little. Oh, I just wanted to see. This is why I do that. I just wanted to see.
I mean, I could see like if I did that, if I put like plastic wrap on something first and then put aluminum foil over it. And then I was like, oh, it just has aluminum foil. I'm just gonna put it in the oven.
Mhm.
And then I forgot that there's plastic wrap on there. And then that's, I don't know. But other than that, I can't think of a reason why you wouldn't do that.
Okay, so Lenise has a question for Rachel. What is your favorite kind of cheese?
Yes. Hi, Lenise. Yeah. So this is always such a hard question because I feel like all these little cheeses are like my little babies, and I love them. And
Relatable.
and they're also like different and wonderful. But you know, there are some favorites. So one of the cheesemakers I work with is Jasper Hill up in Vermont, and they make amazing cheeses. And they have these underground caves that they built, and they age the cheeses there. And so we can go there and like collect the microbes that we want to study. They're incredible, and their cheeses are amazing. And do you have some of their cheese, or you're just eating cheese right now, Raven?
I just want
Is that the foot cheese? No, that's a Gouda. What is that?
something going on here.
Oh, is that a
Oh, yeah.
Oh, there's some mold. Yes. Yeah, just scrape that off.
Eat it.
Scrape it off.
Just scrape it off.
Scrape it off. It's fine.
Cheese expert Rachel Dutton says you can just scrape it off.
But yeah, I love blue cheese. I think I like really strong flavored cheeses. And so Jasper Hill makes a blue cheese called Baileys and Blue. And we actually studied that cheese a lot in my lab. So it's kind of like a science favorite and a personal favorite. And yeah, but Jasper Hill also makes this cheese called Harbison, which is wrapped in bark from spruce trees that are grown like on their farm.
The cheese is wrapped in bark? The cheese itself?
The outside of the cheese is wrapped in bark because it gets so gooey that you can just like slice the top off and spoon it out. So the bark actually like helps support it.
Mm-hmm.
It's amazing. It's amazing.
That's cool.
I highly recommend that cheese. Anyway, those are some favorites.
I like
everyone.
Vermont cheddar.
Ooh, nice.
Cheddar. I love Vermont cheddar.
Yeah.
I am a big fan of a really good brie, but I also like a good blue cheese on my salad. So those are my top two: a good brie or a good blue cheese.
So I like to use blue cheese crumble, actually gorgonzola. I put gorgonzola blue mixed in my ranch when I have like, let's say we're doing movie night and like fries and wings, you know, I like to mix gorgonzola chunks and ranch dressing.
I like that, like blue cheese ranch hybrid.
Yes.
Yeah.
Yes. I have a question though, follow up on this. So the whole penicillin thing, right? Penicillin's found on bread, et cetera, et cetera. So cheese, like blue
penicillium.
cheese. Yeah.
Uh-huh.
Can we talk about penicillium and blue cheese?
Yes. Okay. So penicillium. So the antibiotic penicillin comes from this mold called penicillium. And so penicillium is a big family of fungi, right? A bunch of these different types of molds.
We don't know that. It's the same family, but it's the same thing.
Exactly. So there's only like a few of them that actually make the antibiotic, but there's many, many other types of penicillium molds. And there are two that are really important in cheese making. One is Penicillium roqueforti, which is the blue mold inside blue cheese.
Okay.
So cheesemakers will inoculate the milk with the blue, the spores of this mold. And it's kind of cool. It only grows in low oxygen environments. So it grows inside the cheese where there's like little cavities, or the cheesemakers will actually take like metal spikes and spike holes into the cheese after the cheese is made. And then the penicillium will grow like just along those spikes. So sometimes when you have blue cheese, you see these like lines in it, and that's where the penicillium, there's just a little bit of oxygen, that's where it likes to grow. And then Penicillium camemberti is a white mold that grows on the surface of camembert and brie. So it's another relative in that same family of molds. Neither of them produce the antibiotic penicillin, but they're both really important in cheese making.
So now on camembert and on brie cheese, when you slice through, you have, you know, that rind, and then you have the soft inner parts. Is it okay to eat the moldy rind with the soft inner parts?
Yes, please. Yes. Yes.
One of my favorite parts.
Great. Yeah. And so a lot of times with those types of cheeses, the the closer you get to the surface, the stronger the flavor is, because the flavor is coming from the microbes growing on the surface of the mold. There's also bacteria there that live on the cheese. There's this bacterium Hafnia, which my student Tara Spencer, who I see is in the chat.
She's in the chat.
Is studying from a brie type cheese. And anyway, so there's a bunch of different microbes that grow on the surface, but the penicillium and everybody that's growing there is secreting things into the cheese. And so the closer you get to the rind, the stronger the flavor. But it's for that type of cheese, you're supposed to eat the rind of the cheese, that cheese. And you can eat the rind of pretty much any cheese as long as it's not like wax or something. They don't always taste good, but they're edible.
Yeah.
Palatable. I don't know. Yeah.
All right, so we have a question from This Glorious Clockwork. Hi, hello. I'm late to this, so this might have been asked. What is your favorite microorganism?
Oh my God, that's like
That's
even
good.
harder than picking my favorite cheese. What is my favorite microorganism?
Or even your favorite class of microorganisms. That helps.
I mean, I love bacteria, but I'm also growing to love fungi and viruses. I mean, I just can't pick.
You can't choose.
I love them all. And what's so cool is that they all have like all these different like ways that they interact with each other, and that's what we study in my lab. So I can't pick one.
Janelle, do you have a favorite
Microorganism?
Yeah.
You know what's really, this is really bad, but I'm trying to figure out how to say this without sounding like a weirdo. Whatever, I'm a scientist. I'm a weirdo, and it is what it is, okay? I'm a fan of the STD microbes.
What is it?
You were gonna say that.
The STD.
Wait, what is
microbes.
that?
Not just bacteria or viruses, but like, you know, the particular bacteria and viruses that cause STD outbreaks. STI.
Oh, I thought, okay.
I didn't do like a lot of research on them in the lab, but my master's thesis was about, you know, STDs and yeah. So anyway, I'm kind of a fan of that realm of things. It's really interesting how, like, for example, right? Did you know that when you get like trichomonas or like a UTI, the funny part about those kinds of bacteria is we all know they have cilia or flagella or whatever, but certain microbes are made to stick to the lining of your urethra. They have little like appendages all in their bodies, so that it makes it hard because they know that they're going to be in your urethra, and your body's job is to micturate or to urinate and release fluid. So they have these little appendages that stick to the lining of the urethra so they don't wash out. And I'm like, that is so cool. Like, I mean, it's not cool, but that's so interesting. That they
It is amazing. Yeah.
I told you, whatever. I'm a scientist, I'm a weirdo, and I own it. It's okay. Okay? So it is, that's what it is. All right.
Listen, I think it's really cool. Oh, go ahead.
That's really cool, right? Is that interesting?
Yeah.
No judgment.
Yeah.
No judgment.
Yeah, I'm a weirdo.
So I just this is an interesting story that you remind me of with trichomonas. So my parents have a cat. My mother's an OBGYN. Let's just first start with that.
Okay.
And we adopted a cat when I was young, and her nickname is Trick. The kids named her originally because she showed up on Halloween, trick or treat. Her name was Trick or Treat because it was a Halloween kitten that we rescued, right? And one of her colleagues asked, like, "Oh, you got a new kitten? Like, its name's Trick. Is that for trichomonas?" Anyways, so that reminded me of that story. I thought you guys would appreciate it.
I did.
It is not trichomonas. It is Trick or Treat the cat, but
I really did.
You guys want to see something? This is so bad. So I actually have. So you guys know that I use plushies. So we're in COVID and whatnot, and so now I'm doing a lot of teaching online, right? And so I'm an adjunct faculty part time, and so I've had to find creative ways to do things online, and I use models and whatnot in the classroom, but at home I use a lot of plushies. So I actually have a few STD micro plushies in my
Wait, I want to see. Are they in reachable
Oh.
distance?
I'm right back. I'm right back. Keep talking. I'm right back.
Listen,
I know what
Okay.
she's talking about. Because when I was in Mozambique, I really
I
wanted
have
to
a
get.
bunch of those. Yeah.
Do you?
Yeah, they're cool. Really wanted a plasmodium one to teach malaria
The giant
awareness.
microbes.
Yeah, the giant
Yeah,
microbes. Are so
my favorite is the flesh-eating Staphylococcus aureus because it has a knife and fork.
Oh my god, that's hilarious.
Yeah.
Wow.
Do you
That's a
use them
lot.
for teaching at all, or do you just have them?
I just have them. They're actually, my lab got me a bunch of them when I had my
Aw.
daughter as like
That's
baby
sweet.
toys, I guess. for a microbiologist's daughter. So.
That's a cute idea,
So
though.
helpful.
I get it. Oh, they made a coronavirus one. I'm on their website. They made a coronavirus plushie.
I wouldn't be surprised.
At Giant
Is it
Microbes, if you want to sponsor us, call us.
Please.
Wait, while we're talking about stuff, I just want to plug Bump real quick. So Bump at UCSD, BUMMP, UCSD.org. You can go on their website and see what they're all about. It's a mentorship program run by the Division of Biological Sciences, and we're trying to get undergraduate and master students, people that will support them. Thank you. Yes, thank you, December. Yes, we're trying to get some donations so that we can support research, undergraduate and master students, like to fund them to do research in labs. I did research since my freshman year and I was never paid for it until I got into a PhD program. And it's really difficult if you don't have any, like you have to get a job or all this other stuff, and school, job, research lab is a lot. So if you can spare some coins and go to bumpucsd.org, and you can read more about what their mission statement is and how you can help support these people. Yay. Thank you.
Thank you. It's an amazing program. It's so amazing.
Yeah, I'm a mentor. I think Rachel's a mentor.
I'm a mentor, yeah.
Yeah, so we're definitely involved in trying to make sure all of our students are where they need to be.
I love that.
Okay, I think Chanel's back with her microbes.
I'm back. So I had a syphilis one, but I think my cat is knocking around somewhere, so I can't find that one. But here is the trichomoniasis microbe. And here are the little, here's the flagella. Actually, I think the cilia. And here's a little wave on the side. But yeah, so these things, they stick inside of the wall of your genitalia. And that's what causes the irritation, because they're able to stick to the walls of your genitalia. And then I also have one. So I got this one on purpose because it's obviously, you'll know what it is when you see it. Can you guess what this one is? It's not a microbe though. Can you guess what this one
I
is?
know what that is.
Can you guess what this one is?
Is that
Oh my god.
It is. Yeah. It is. It's a crab. It is. So pubic lice. Yeah. So pubic lice are actually, they're allowed.
How did we get to here? How did we get to
the naked eye? And so
Welcome to STEMbassy.
yeah. So yeah. So if you take my class, okay, this is the kind of stuff that I'm talking about in public health and nanophysiology. You know, these are the kinds of things that I'm talking about in my class. So anyway, but yeah. So yeah, trichomoniasis is one of my fave microbes because I talk about it in public health and STDs, and so.
I mean, now it's cute, even though it's dangerous and irritating, but it's cute.
So look at the face. Look at the face. It's actually not cute. Look at the face. It's kind of like
from a distance, it looks
like this,
cute.
like this.
Oh yeah, no, I don't like it. Oh, okay, I can see it now. No, just a color.
It's walking like, I'm gonna get you.
Is that what you say in class?
No, well, I mean, I tell them that if they're not careful, yeah, it'll get you. If you're not careful,
make it plain.
Yeah. Alrighty. I think on that note, it might be time. It's a little late on the East Coast.
Yes, it's late on the East Coast.
Rachel, thank you so much. Thank you so much for having this conversation, because it opened up the doors for other conversations. Thank you.
Perfect.
Amanda, take it away.
Okay, yes, thank you all for joining us on our first little episode of STEMbassy After Dark. Our regular season is over. We're going to be doing a little bit of info dumps through our STEMbassy After Dark series. It's a little more casual, but we still want to get you guys some important information that's going to keep you safe and keep you informed about what's going on in the world around you. So thank you again, Dr. Rachel Dutton. We are asking for fundraising donations for the BUMP program, BUMMP, UCSD.org. Please, if you can spare anything, it's really kind of you. And Rachel, is there anything you want to plug? Is there anything? Usually we have people that are like writing stuff, or you want to support something. Like you can. This is a minute of you. Go ahead and plug whatever you want before we close out the show.
I mean, I would love to see more people support the BUMP program at UCSD. So one of my grad students, Tara Spencer, is one of the co-founders of the program. It's just this amazing program that's filling this need to provide mentorship and a more inclusive environment for underrepresented students at UCSD. And we have such an amazingly talented pool of students there. So we really want to make sure they have all the opportunities to succeed that they can. So it's a new program. It's amazing. It's run by amazing women in science. So that's what I will say.
Great, thank you. So with that, everyone, STEMbassy is now adjourned, and we'll see you in the very near future.
Bye.